Hi everyone, welcome. We're thrilled to be back live from our Tel Aviv office for another insightful panel discussion. Thank you so much for joining us today. We have a very prestigious group of panelists from across the artificial intelligence system here with us today. I'm Noemi Aliel and I'm the director of Starburst in Israel. Together with Avital Vilkin, I manage the AI International Innovation Center and I scout for the hottest Israeli startups in the aerospace and defense sector, and I help them gain tractions within the corporate and venture ecosystem. Following the roundtable, we will be using the Q&A features that you could see at the bottom of your screen to get some of your question answers. Please use the upvote features within the Q&A to ensure that we're asking the most pressing questions. But first, I'd like to hand over the mic to Francois Chopard, the founder and CEO of Starburst, to say a few words about what we do and share his perspective about current trends in AI for aerospace. Francois, I invite you to open your video and your mic.
Yeah, is that okay? Can you hear me?
Yes.
So again, thank you, Noemi and Avital in Tel Aviv for organizing that conference. Thank you everyone for joining. Very excited to have you, and thanks to all our panelists to participate. And I'm sure it's going to be a very exciting discussion. As you know, Starburst is investing in early stage startups in the aerospace and defense industry, and I would say more and more in the defense industry. AI has been a key topic for the last 3 to 5 years, even though we all know that the mathematical techniques of AI have been existing for like 20 to 25 years. It's with the increase of computational power and new embedded device, it's been possible now to have AI on board of a new type of device and new type of a product. And so we've seen AI emerging in the most famous one was then a fighter pilot in the US lost against a machine in a dogfight combat, and that was 2 or 3 years ago. A software developed by a team of students from I think it was either University of Pennsylvania or another one. Since then, that startup has been quickly acquired by Thales, and Thales was competing with Boeing and Lockheed to acquire that company. So just to highlight that AI has been hot among startups and researchers that have spin out their technology and their idea into startups, but also hot on the large corporate side, and looking deeply to invest in this technology, acquiring early on stage startups at basically any cost. Since then, we have also invested in AI startups, one in Canada to do pilot training, another one in the US to do Earth observation image recognitions. And there's, of course, much more applications to come, and we'll announce more investment to come. So it's in the mind of everyone, especially in Tel Aviv and Israel, where the country has been already so strong in implementing new type of software technique and combining software and physics. And so we are very excited again to have you on board and to listen to what you have to share, your view. How do you see the future on what's technology or application you want to invest? And so thank you again.
Thank you very much, Francois, for these words. So in this roundtable, we will talk about the future of AI in the aerospace and defense industry. And we will show you how it has become a force multiplier on technological progress in this world, which is now increasingly digital, data-driven, and it's also leading to increase in production efficiency, and it's enabling autonomous flight. And so just before we dive into the panel, I wanted to highlight how AI intersects with the aerospace and defense industry, and starting with the predictive maintenance. So what we've seen there is that the advancement of AI and machine learning in predictive data analytics is basically allowing aerospace and defense company to save cost. It's solving inefficiency. It's solving by reporting in advance potential failure, and it's saving time and money ultimately. The next area that is affecting the aerospace industry is with training and virtual assistance. AI is driving the evolutions of pilot trainings in a new directions by creating more realistic and to the point scenarios on simulators. It's also touching the production side, paving the way for generative designs to take over the manufacturing process. It's helping the industry manufacture new aircraft parts faster and cheaper than ever before. And last but not least, it's affecting the drone industry with an unprecedented increase in the drone industry for things like surveillance, security, delivery, and defense. It arises the need for better control, for smarter handling with reduced human interventions. And new AI algorithms that are equipped with better computer vision techniques are making all this possible for us. At Starburst, we've scouted to date something like 689 early stage startups that are related to AI. And we have also a few in our late stage accelerators and in our portfolio companies that are basically spanning across all major segments of the AI spectrum. Starting with the geospatial analysis, we have Orbital Sidekick, another company called Deepwave Digital. And then on the drone side, the autonomous device, rather, we have Sightec, which is with us on the panel. We have Skyways, Coroneva, and we have a company called White Fox, which does security enhancement. And on the user engagement side and support, we have Paladin AI. So without further ado, I'd like to kick off this panel with our first panelist. I'd like to invite Professor Ginosar. Ran is a professor at the Technion, which is where he's leading their very large-scale integration system research center. He's also the co-founder and the president of Ramon Space, which builds space-resilient supercomputing system that brings cloud computing to space. So Ran, can you please tell us a bit more about the hot topics that Ramon Space is working on around AI and how your technology is addressing the growing needs of new space players?
Thank you. We address the entire digital part of payloads in spacecraft and satellites. This digital part is dedicated for typically signal processing and recently more and more artificial intelligence or machine learning tasks. New space usually means better performance and higher level of integration in space. And it's also very disruptive on prices, especially in relation to the unreasonably expensive old space. In this market, we address mostly the telecom and observation segments, which are the largest and where most of the investments and expenses are being made. We work on advanced all digital aspect of both of those applications. For example, in observation, we work on high throughput data capture, on mass storage, on image processing and computer vision, mostly with AI, and compression and on transmission to the ground.
Okay, thanks, thanks, Ran. So our next panelist knows Ramon Space pretty well. It's since Renana, you've invested in them. So I'd like to introduce Hernan Ashkenazi. She manages the investment team at Growth Ventures. It's a $120 million early stage deep tech fund that is based here in Israel. Growth was established by Dov Moran, the inventor of the USB flash drive. Renana also has a master in engineering. She's a captain in the IDF reserves, and she served as a technological officer in the military elite intelligence unit 8200, or in English 8200. Renana, I think our audience would be very interested to hear about your perspective around current investment trends and new applications in AI for aerospace. From downstream data to image processing and big data analysis, we increasingly see this new vertical services and use case. So can you please tell us what you think are the hottest topic in AI for the aerospace and defense industry these days. And the second question is, what are some of the investment trends that you've observed?
How much time do we have?
2 minutes.
I mean, lately it seems that it doesn't matter what's the question, the answer is AI, right? I mean, in almost every vertical you look at, from the chip industry, automotive and healthcare, machine learning and AI are probably the most important innovation trends of our current time. I think someone sent me a report that said that 80% of top-level executives within the aerospace and defense industry believe that every aspect of the workforce will be AI influenced by 2021. There are endless areas in the market for AI to create disruption. I mean, if we look at the satellite industry, for example, then AI is one of the latest buzz terms. It could potentially have a significant role in various aspects, I mean, including system manufacturing, adding value to applications. You mentioned some of those. Earth observation, it's a classic, right? If not the most classic use of satellite deployment, and images taken from above can be used for a wide range of use cases, from understanding the effect of natural disasters to espionage. And AI in space opens up a completely new chapter in Earth observation by adding scale, automated image tagging, and map correlation. And combined, those can be used for entirely new applications, right? Such as understanding the economic state of a third world nation. But those are the obvious, right? I mean, data and what you could do with those huge amounts of data that you can now extract meaningful insights from, those are the obvious aspects. There are also a ton of like more boring things, right? Product design. In the aerospace industry, lightweight and durable components are key in design. And now, using AI, manufacturers can explore multiple options without wasting time and with much reduced costs, and improving maintenance and operational efficiency. So speed and air pressure and altitude and temperature, those are all monitored using multiple sensors in an aircraft. So using AI, you can now collect and analyze all that data in no time. You can alert for abnormalities and suggest the best way to fix an issue. The opportunities are really endless. I mean, think about fuel consumption or fuel efficiency. Even a small improvement in an aircraft's fuel consumption can have a huge impact on emission and the company's bottom line. And AI-powered systems are now helping to optimize fuel consumption by using machine learning models that prior to each flight optimize climbing profiles. Apparently, and I didn't know that, aircrafts have higher fuel consumption during the climb phase, so by optimizing that phase, you could actually reach significant fuel saving. I mean, there's really no place in the industry where AI can't significantly improve whatever's being done. You mentioned training. Think about customer service, right? I mean, if Sephora and H&M have implemented AI chatbots to help you find your size, then there's absolutely no reason that it can't be implemented in booking and cancellations of flight tickets. So bottom line, it's really difficult to narrow down what's interesting. Everything's interesting.
Maybe by the end of the panel, we'll have a clear idea of where it's leaning. So speaking of hot topics, I'd like to invite my next guest, which is going to speak about AI-powered autonomous flight. Roy is the CEO of Sightec. He develops real-time computer visions for autonomous drones. Sightec is currently in the Starburst late-stage acceleration program and has already conducted successful collaborations with some of our corporate partners. Just 3 days ago, IAI, or Israel Aerospace Industry, introduced their multiplier, which is a fleet of small helicopters UAV designed for non-military tasks, and it uses Sightec's AI-powered optical scanning technology to enable the autonomous and efficient scanning of large areas of territory. So Roy, first, congrats on the successful demonstration. And second, how does your technology work? How is Sightec using computer vision and AI to give the drones the ability to analyze what they see and respond in real time?
Thank you, Naomi. I'll try to explain what we do at Sightec. Our focus is on machine vision within the AI world. Sightec develops real-time machine vision software that helps autonomous drones to safely navigate and land, and also to perform their missions precisely and effectively. And if I'll drill down into what it means, we develop image-based navigation software that helps the drone to navigate, for example, in GPS-denied environment. This is a big challenge in the autonomous drones market. And when you take the pilot out of the loop, you have the challenge of making sure that the system can be performed in the safest way possible. And the way we do it with our software, we compare in real time between the video image and the reference map. And you need to do this matching in real time in a way, if I try to explain that in an intuitive way, we are trying to imitate the pilot's ability to understand where the drone is without relying on any external resources like communication or GPS that can fail. And when we talk aviation, we talk about redundancy and maximum backup. You don't want to rely on a single source for anything when you want to move beyond line of sight. And a second product that we developed is a very effective autonomous real-time detection and tracking system. And the idea here is to provide affordable, real-time actionable insights to the operator. And we do that by using very light payloads that can cover large parameters. And we do that with minimum resources, because when you conduct a complex mission like the one that we are doing with the Israeli Aerospace Industries, you have very limited resources in the field. And everyone who deals with drones and autonomous mission knows that when you get to the field, you are limited by communication, you are limited by the hardware, you're limited by the number of people involved, and you want the mission to be most effectively. So in this project, for example, with AI, the multiplier product that AI introduced earlier this week, we integrate both products, and you get a full autonomous mission in which our software helps the drone to get to its destination without relying on external resources like GPS. And when it gets to the area itself, to be able, for example, with a single camera, to cover 1 square kilometer and identify very small objects in the scene.
Sounds very cool, Roy. Speaking of the field and analyzing data in the field, let's invite our next panelist to tell us how AI is impacting the military. Our next speaker cannot be shown on camera for security reasons, and we're going to refer to him as Lieutenant Y. He's a researcher in a special unit of the Israeli Defense Force under the Joint Chief of Staff that acts a bit like a think tank to generate innovative projects and to build proof of concepts for all the divisions before it goes back to the division for further development and deployment into the field. He's also a contributing author of a book about AI for the Israeli Intelligence Corps that is soon to be released. So Lieutenant Y, can you please explain a bit more about the role of your division and elaborate on some of the most successful projects that you worked on that used AI and how it has benefited your organization?
Hi, thanks. I'm glad to be here. So like Renana said, AI influences everything. And so our divisions, so we must also be everywhere and help every division in their AI efforts. We worked with the Air Force, we worked with the Navy, we worked with intelligence, we worked with basically with anyone who would work with us and would like to try to develop an AI project and be helped by our expertise. Our main efforts naturally tend towards the operational kinds of projects, but we also worked with budget. We also worked with HR, I think. And I think in many ways, these are the so-called boring projects. In many ways, they are the most influential ones because the, the army is a business like any other business. We have huge budgets. We have huge amounts of people we must use for all kinds of different stuff. And we would like, and so one of our projects was to try to assess whether people who just finished 12th grade, how good programmers they will become. and another one was working with the budget people. So we tried to assess which units will not use their budget efficiently. They will need too much budget or maybe not use all of their budget in the following year. So prevent inefficiencies. So while they're not maybe especially technically challenging, they are very, in dollar sense, they are extremely valuable. Yeah, so it's a very interesting position to be in, to just watch the IDF's digital transformation and the AI transformation. We have the eagle's eye view on the AI transformation in the IDF, and it's very exciting.
For sure it is. Thank you, Lieutenant Y. So AI is not just transforming the defense industry. Big data is actually changing the game in the space industry, from Earth observation imagery analysis to satellite tasking optimization and mission planning. My next question is for Renana. Renana, could you please elaborate on how the geospatial analytics are disrupting the new space industry? What are making this change possible? In other words, what are the key drivers for AI development?
How much time do we have? I'm kidding. I mean, today, the future of Earth observation, it doesn't depend only on providing data, but also on providing Earth observation data analytics, right? It has become imperative for both businesses and users to understand the scientific, the socioeconomic, the environmental benefits that are derived from Earth observation data analytics. And I think I read an interview with a Planet executive, I think, and he said the future of Earth observation is moving from data to analysis ready data. There's an acronym, so you know it's true, right? ARD. That is in the ability to generate insights using automatic procedures and bring value to customers. I saw another report that found that downstream segment, which primarily includes imagery and map analytics, the market is expected to touch 42-something billion by the end of the year of 2020. This steady growth, if you will, of Earth observation data and analytic solutions enables the use of analyzed satellite imagery for informed decision-making across all economic sectors, right? With satellite producing increasing amounts of data, advances in onboard processing of data will facilitate near real-time transfer of data, enabling users to make smarter and quicker decisions. And if we, Juan was talking about Ramon.space just a minute ago, and what's most exciting to us about Ramon is that they're developing high compute processors that are rod-hard, right? They're resilient to the environment of space, and they support on-the-edge real-time processing of those huge amounts of data, and understanding that without online processing capabilities, then much of the value is lost. And of course, we can't have a Zoom panel without addressing COVID. So using satellite imagery and analytic software, geospatial data companies track the global impact of the pandemic. They forecast trends such as a shortage of supplies and identify areas where there could be new outbreaks. And even it's funny, if you look at the recent marketing pitches by geospatial analytic companies, then you can get a glimpse of the examples of how data is being turned into intelligence in the pandemic. Orbital Insight, I think it was Orbital Insight, they gave a presentation with a slide titled China's elite are golfing again. And they showed the analysis from images taken of a resort island visited by Chinese businessmen and politicians. And the company wrote, as the world questions China's recovery, we have seen a surge in traffic at the resort, offering a glimpse into the mindset of China's elite. And Black Sky had a briefing, and they showed the results of an analysis of satellite imagery from different US cities that looked at whether the population was complying with social distancing and how the pandemic was inflicting economic pain. So data collected over a city in Ohio, I don't remember which, for example, showed that many large manufacturers in late March were beginning to close despite early claims of minimal impact from the pandemic. So the crisis is really raising awareness of what data can do, not just to help governments respond to events, but also prepare for future emergencies. Geospatial data provided by satellites can help guide decision-making, right? And see those impacts even before they occur, so that we can plan for them by monitoring human behavior, such as the size of the crowds on Florida beaches. Governments can forecast potential spread of the disease and move resources to help combat it. The opportunities, like I said in the beginning, the opportunities are really endless.
Wow, they should bring this technology to Israel. Fascinating. Thanks for sharing, Renana. So my next question is, because you mentioned Ramon, we're going back to you, Ran. I want to talk about how things like predictive maintenance, generative design, and other uses that we see in the uses of AI that we see in the aerospace world heavily uses data analysis or data sets, sorry, to extract or extrapolate info. So Ran, how do you think we could increase the access of high quality data from the aerospace industry so that we can better train our machine learning models?
Yeah, so the key issue is word high quality. And we see ever mounting challenge, beautiful challenge for us with a request to very high quality data. For example, what used to be sufficient quality of images for human consumption is no longer good enough because for training and for inference in machine learning, people require much higher quality images with preserving most of the features that have been captured and much less of lossy compression on the way down. So that's one thing. The other thing is that there's a growing need for transmitting the data down to Earth. And there's a very limited link that to push all the data, but we are working on newer and newer modes of communication that enable us to increase tenfold and 100-fold the bandwidth of data going from space down to ground. And the third thing is that, of course, that opens the door for a lot of machine learning applications in space, processing the data in space, because there is no way you can push the huge amount of data that's been collected in space to the ground. So some of the training, not just the machine learning inference, but also the training seems to be going slowly going up into space. And in the future, we see a need for massive storage and massive computing capability similar to the cloud. And that's why we talk about clouds in space for these reasons.
Okay, thank you, Ran. So my next question is addressed to Lieutenant Y. The IDF's mission is first and foremost to protect Israel from outside threats and attacks. AI is among the many hot technologies that promises to change the face of warfare for years to come. It will increasingly process defense-related information. It will filter such data for the greatest threats, and it will make a defense decision based on its program algorithm. And perhaps one day even, we can have direct combat robots. AI and big data enable the soldiers to analyze and to extract information from the field and connect information channels together. So Lieutenant Y, how did the IDF harness the power of digital transformation, and how did they apply it to the operational environments that they live in? And how has it changed the battlefield, according to you?
So I think the AI age really lets IDF's advantages shine because we have huge resources, we are a very technological army, and so we can really use the digital transformation. I think we can take one of our projects of border surveillance and try to understand it through that lens, because there are soldiers in Israel, because we have many cameras in Israel all around our borders, and there are soldiers whose purpose and job in the army is basically just to watch these cameras endlessly and try to detect threats, trying to breach the borders. It's a very intensive job. It's very hard. It's very monotonous. People just can't concentrate for extremely long periods of time on cameras in which nothing ever happens. And when it happens, it tends to be for very short time because people will just approach the camera and pass it, and then it will not be seen. So So first of all, we just connected these cameras to a central database, and we are storing all of these streams constantly, and we are trying to take all the possible, and then when we have them on storage, we can take all of the possible events and then train models of them and try to let the soldiers only watch cameras where we think there might be something interesting currently happening. So there might be herds of sheep, there might be agricultural activity, or there might be a terrorist, and we try to separate them. We try to just differentiate between them using the AI. So in general, Israel has a strategy of protecting our borders better and better using all kinds of sensors and data. And so this is just one example of the stuff we're doing and we're using AI to take all of this data and all of these sensors and try to automate them to make them more and more usable.
Thank you, Lieutenant White. I'm sure there's many more uses that you just can't speak about, but I'm very grateful that you've shared what you could. And speaking of changing the battlefields, I want to turn back to the drones, which are for sure must play a big part in that. So Roy, the next question is for you. Israel is known to be one of the largest exporters of drone in the world and a pioneer in anti-drone technology. How big of a role does AI integrated drone play in securing Israel's market position in the global drone industry, and how AI is influencing the drone industry in general?
Right. So I believe that as the drone market matures, the focus will shift from the platform itself to AI, where differentiation can be achieved. So it's, in a way, it's quite similar to what we saw in the mobile market more than a decade ago, where you saw a shift moving from the device itself. It was back then all about the device, to the smartphone applications and what the device can enable. And when it comes to inspection missions and autonomous missions, the job to be done at the end is how to effectively collect and analyze the data. In a way, the era in which we are part today, our era is an era of digitalizing the world and mapping the world and collecting huge amount of data. And the challenge is on how to collect the data, how to store the data, how to analyze the data. And customers, at the end, they want to get the data they need in a simple and affordable way. And to do that, you need smart AI that can replace the people in the loop, because today the entire operation is very complicated and expensive. So you want to reach a point in which you can use less pilots in the mission, you can use less analysts that analyze the data. It's the huge amount of data that is being collected. So from my point of view, the future market will look for smart technologies, smart AI technologies that can help perform autonomous safe operations on one hand. Again, we are dealing with aviation, so everything has to be safe to the maximum possible. And you want to enable missions in which multiple drones can work together in a fleet and perform effective inspection missions with minimum resources and people involved. And because we need to remember that the market is maturing and there are fascinating technologies that are being presented today, but at the end, the holy grail of this technology is to help the end customer to perform a mission in a very simple way. And to get to simplicity, you need AI, because you're trying to imitate what we do, what people do in a very intuitive way.
So it takes the complexity to get to simplicity, in a few words.
For sure. And just to complete your second half of the question, same for Israel. Israel started with lots of innovation around the platforms, quite amazing UAVs. And today, those UAVs are transforming to be smarter with AI integrated. And I think that this is where also the Israeli market will head in the next coming years.
Cool. Thanks for sharing your thoughts, Roy. And you mentioned things like safety and autonomy and swarm intelligence. We're going to talk about that again in the next part of the panel. But first, I want to direct my questions to Ran from Ramon Space and discuss a little bit about cloud. AI is traditionally being deployed in the cloud because the algorithm crunch massive amounts of data and consume massive computer resources. And you touched upon it about it a little bit earlier in the panel. But AI does not only live in the cloud, it also sometimes needs to be made locally, like you gave examples in the case of space and satellites. And it's not close to the edge of the network. And lately, what we've seen in the market is that there's been a reach by industry giants like Apple and Microsoft to push AI to the edge. For instance, Apple, they bought a company called Xnor.ai, and Microsoft Azure, as they offer the Azure IoT Edge that allows AI workloads to be moved to the edge of the network. So my questions for you, Ran, is, will AI continue to be moved to the edge? And then what are the benefits and the drawbacks of AI at the edge versus AI in the cloud? And how can the aerospace company better balance between the demands of centralized computing and the needs for localized decision-making? Ran, you're on mute, so you have to remember to unmute yourself.
Yeah, I've said that in the long term, we work on developing cloud in space, but in the short term, everything is edge. So whatever we do in space today with artificial intelligence and machine learning is what you might say edge. And AI moves to the edge only when it must, but there must be very good reasons to do so. And we see two types of reason or motivations. The first one is when the required time to results is much shorter than the time that it would take to go to the cloud and come back with results, then you have to do things locally. And for example, if you need to identify an object in an image at real time and respond to it immediately, there's no time to wait until a satellite goes over a ground station, transmit things down, maybe have a human look at it, and so on. So sometimes you have to do a sub-second or split-second decisions. It's not just observation. For example, in telecom and in networking in space, you have to manage frequencies and mitigate interferences, and even talk about cyber attacks, and all that has to happen immediately. And so there's a lot of edge type of machine learning that has to be done right there at the edge in space. The other set of reason is just because, like we said earlier, there's an insufficient bandwidth to bring the data down to the ground, bandwidth and time. So sometimes you have to reduce the amount of data before you bring it down to the ground, because some of the data is not needed. So you said earlier, somebody, I think Renana said earlier, you convert data into, let's say, information or analysis results. And you have to do it sometimes in space because, for example, you want to screen a lot of images and throw away all the images with clouds that, which really show you nothing useful, instead of waiting and clogging all the networks to bring all these cloud pixels down to the ground. And at the end, you just throw them away. So you have to do this kind of screening up in space. And most of it is not simple processing. Today, it's more and more done by smart algorithms and machine learning. So that's the edge in space.
Thanks, Ran. Yeah, and speaking of data and advanced data fusions, my next question is for Roy. Roy, it enables, advanced data fusion rather enables those vehicles to autonomously navigate into complex environments, coordinates with other airborne objects, and accomplish missions with no or minimal human interventions, even when it's in a GPS-denied environment, like you mentioned earlier. And a lot of efforts around AI for autonomous vehicles, like perception and navigation, or collision avoidance, or flight system optimizations, are all aimed at increasing efficiency and safety. So I want to kind of zoom in on that. And I want to understand, where do you think the line between AI and human control should be drawn when looking at flight safety? How do we open up our skies to a safe and reliable air mobility? And hopefully sometime soon, when can we see flying taxis? Roy, if you're on mute, you have to unmute. Okay, so I think Roy is no longer in our panel. He must have some technical difficulties. So Roy, you just came back. Roy, are you back with us? Did you hear the questions, or should I repeat it? You're on mute, Roy.
Please repeat, because I lost.
No worries. So I'll skip the intro because they already heard the intro, but the question is, where do you think the line between AI and human control should be drawn when looking at flight safety? How do we open up our skies to safe and reliable air mobility, and hopefully sometime soon to flying taxis?
So in the aviation world, in the aviation market, I think it's quite similar to what we see in the autonomous mobility market. And it's all about safety. And when you look at the future of these markets, I think that the regulators will be very cautious about allowing, first of all, even inspection missions beyond line of sight. And then the next one is, of course, as we see today, drone delivery, and at the end, urban air mobility, which is the future of flying taxis. But the market will need to move there very slowly. We will need to check the box on maximum safety levels. And I think that as the markets mature and technology matures, people realize that we need to be realistic about replacing people altogether. So in the autonomous mobility market, I think that projections towards when we will see level 5 are kind of pushed further. And if in the past people talked about 2030, now people push that maybe in 10 years. And I think that in the autonomous flights market, we are going to see more flexibility when it comes to things like drone delivery and predefined routes for autonomous drones to deliver a package. And we already see that in the market. And when it touches things like delivery of people, I would expect, I think that analysts quite agree about that at the beginning we will see semi-autonomous missions. You don't want to replace necessarily the pilot, but you don't want the pilot to be as sophisticated as today. So today a pilot is, a very well-trained human being, and not everyone can perform this type of missions. Naomi, you are a good example for that as a pilot. And I think that in the future, if we can move to a world in which AI can help perform some of these functions, and by that reducing the skill set of the human being in the equation, that will be a big breakthrough, which will bring us to level 4, for example, which will be another step towards a future of full autonomy.
Okay, Roy, so no flying taxi anytime soon. We'll stick to helicopter.
No, I'm saying flying taxis with pilots at the beginning,
yeah,
in a predefined route, and further down the road, something that will be fully autonomous.
Okay, safety first. So speaking of safety, what about security risks? And so my next question is for Lieutenant Y. It's another hot topic around AI, which are called neural networks. I'm not even sure I'm saying it properly, but basically these computing systems which are vaguely inspired by the biological brain. Neural networks could be trained, for example, to pilot drones or a taxi and then drive a car, and so many more cool things like the Face ID that unlocks the feature on your smartphones. However, these neural networks are extremely susceptible to adversarial examples, which in the wrong hands could be used to cause harm and pose very high security risks. So Lieutenant Y, you recently wrote an article about adversarial examples in a military context. So my next question is this. First, can you explain to all of us what are adversarial examples? And then how can they trick the neural networks? And how can organization protect against those adversarial attacks?
Okay, so as you said, basically, okay, in simple terms as much as possible. So as you said, neural networks are used in basically everything that might use voice or pictures or anything. So basically all the AI, the recent AI revolution is based on neural networks. And in 2014, we discovered that by introducing imperceptible changes to the neural networks as inputs, we can make them say whatever we want. So for example, we can take a panda's image, make some imperceptible changes so to a human, it will still look like a panda, a completely regular panda. And the neural network will tag it as a toaster or as a theater tool or anything we would like. So, and then there were further advances. People created an adversarial sticker where you can put it near anything and it will say, and the neural network will think it's a toaster. Or in another article, researchers printed a 3D model of a turtle, which no matter how it was, no matter from which angle it was seen with the camera, the neural network thought it's a rifle. And obviously the other way around is more disturbing as we use a neural network to, for example, detect threats in airports. You might think of making a rifle which will look like an innocent object, so to a neural network. So in military, this is even more disturbing as we are by definition in an adversarial environment. Think of a plane where your communication devices must always assume that the enemy is trying to jam them, or take the project on which I talked in the previous question, where we have cameras which we use to survey our borders, and some threat might try to go inside to approach them and make the neural network think it's a completely ordinary ship, and so to ignore it. So we must address this issue in all of our projects. We must think whether the enemy might be able to do that, how hard will it be? We must try to hide whenever we are trying to use AI, we must hide the specific ways we are using them, so to make harder for possible threats to breach our defenses.
Okay, so what I got from that is A, it's disturbing, B, it's like it works like an invisible filter, and that there's no foolproof way to really protect yourself from attack, or is there?
For now, there hasn't been published anything in academia which might protect from this threat. It's an ongoing research subject.
I'm sure all the armies around the world are researching it, not just you. Okay, so still on security risks topic, and you mentioned it before, but let's look at AI-powered surveillance. And Renana, that's for you. So Israel has a large number of startups using AI for things like biometric identity, facial recognition, and also imagery analysis. And in recent research reports that use those neural networks that Lieutenant Y just talked about, that would be combined with the computer vision system, and then they use that for mass surveillance. And so it's indicating that it's growing in technical sophistication. And as AI improves our ability to detect threats and deploy countermeasures, both in the physical for ground and airspace security, but also in the digital world by leveraging big data solution and enabling continuous surveillance. This obviously could be good for public safety, helping the people, the police and the first responders to more easily spot crimes and accidents, but it also raises serious questions about the future of privacy. So Renana, what roles do you see these startups play as we come up with new applications of using AI to transform the defense industry? And when AI-powered surveillance finally becomes common, who will regulate the algorithm?
Yeah, so those are I think two different questions. I mean, the impact of AI on defense and then regulation, two are important. First, I think it's clear that AI will have a major impact on existing defense capabilities, such as cyber defense and defense logistics and the ability to collaborate internationally. And there's probably no part of the defense industry that will not be impacted by this, from back office to the battlefield, from undersea to cyberspace and outer space, and all the points in between. If you look at robotics and its marriage to AI, then, I mean, that's probably going to be one of the most substantial impacts of the defense industry. So that's defense. Now, when it comes to regulation, that's a whole new aspect of the story. And there's a lot of buzz around that. And I think it was February of this, the European Commission published a 30-page white paper called On Artificial Intelligence, a European Approach to Excellence and Trust. Basically, it says a lot of things, but also supports a regulatory and investment-oriented approach with two main objectives. One is promoting the uptake of AI and addressing the risks associated with the certain uses of this new technology. And the purpose of the white paper was to set out policy options and how to achieve these objectives and proposals for key elements of future regulatory framework. And there have definitely been growing calls for stronger regulation of AI. One of the stories that made a lot of noise early in the year was kicked off by the New York Times, and it had to do with a startup called, I think it was Clearview Ai. The company's, they had a facial recognition app that identifies people through the use of a database of images that was taken from social media. And the app compares a photo to a database of the company that had over 3 billion pictures coming from sites like Facebook and YouTube. And once the app finds matches, it responds with links to the site where the photos originally came from. Now, this could, of course, lead to discovery of personal details about an individual. And according to the New York Times, the app has been used by over 600 law enforcement agencies. Now, Clearview had a database of over 3 billion images, and the FBI, just for reference, has about 640 million images of US citizens. And that, of course, caused a roller coaster. So the state of California just decided to pass a bill that bans the use of facial recognition technology by law enforcement agencies in California. And such stories are obviously causing a ton of concern about, among privacy advocates about potential mass surveillance use. Another concern is the ability of inaccuracy, right? Is the possibility, of inaccuracies with technology leading to law enforcement targeting innocent individuals. And on top of all that, on top of all the privacy concerns, companies like Facebook and Google and Twitter are now threatening legal action. So that's fun too. And when it comes to biometric data collection and surveillance, then there's often a lack of clarity around what's ethical, what's safe, what's legal, and what laws and regulations are still needed. So now we're seeing startups creating tools to monitor AI and promote ethical AI usage. Startups are attempting to design tools to help AI engineers quantify and qualify how their machine learning models perform. There's a startup called Arthur that's trying to give AI developers a toolkit to make it easier for them to discover problems when designing financial applications, like unveiling biases in investment or lending decisions. And specifically, Arthur's effort and a lot of startups in the domain are aimed at addressing what's called the black box problem of AI, right? Which describes how, unlike traditional code, which can be easily interpreted by those who know how to read it, machine learning systems map features to behaviors without unveiling the reasons that those behaviors were selected or how the features have been interpreted. So it's both a public as well as a governmental effort, right? The EU and the US are already starting to develop regulatory proposals, and international alignment will be critical to make global standards work. There was an executive from Google who recently said that he was talking about AI regulation, and he said that companies such as Google cannot just build promising new technology and let market force decide how it will be used. It is equally under their responsibility to make sure that technology is harnessed for good. So there's no question that artificial intelligence needs to be regulated. It's too important not to. The only question is how to approach it.
Thanks, Renana, for this very thorough answer. It's for sure something that there will be more and more regulations as we kind of wrap our heads around what is AI and what are the implications for society. So let's take a small pause. We're a little bit behind schedule, so we're going to ask now our panelists to adhere to the strictly 2 minutes answer and keep their answers short and to the point. And so far we spoke about AI-powered ships with Ran, with AI-powered autonomous drones with Roy, and AI-powered surveillance with Lieutenant Y. And now what I'd like to do is to take a look towards the future. So Ran, next question is for you again. The emergence of abundant data computing is changing the software-hardware balance in a dramatic way. There's diverse AI application in facial recognitions, virtual assistants, also autonomous vehicles that are sharing a common feature in that they are all relying on hardware as the core enabler of innovations. So what do you think are the key drivers of growth in AI hardware, and how do you think they'll shape markets in the next few years? Ran, again, you have to unmute yourself.
We see 3 groups of rules or drivers in this. The first rule is that there is no rules. And the reason is that the theory and the practice of AI in general and machine learning in particular makes such a fast progress. People publish new things every 2 weeks. So it's very hard to optimize AI hardware to a set of well understood algorithms. And rather you have to change it all the time. So that means we have to create hardware that is much more general and maybe not 100% optimized for yesterday's solution, and hope that we can continue and chase this. The second set, of course, is that as we go towards the edge, it's well understood that edge AI hardware is different than the AI hardware that you build for servers or for the cloud. So you do more inference and you do training. You have to worry about low power. You have to think about low latency as opposed to very high throughput. And that implies using smaller data sets and optimized data movements, unlimited processing rates, and think very well about reduced precision, how many bits per element, and so on. So these are well understood. The third thing relates specifically to us. We have to work in space. So we'll look for solutions, AI hardware that are high reliability, can operate in space, that have to be very long lifetime. The typical 7 years of a terrestrial chip is not enough. You have to design for at least twice as long. And that's why we cannot really take advantage of most COTS devices, commercial hardware that's available on the market or is being developed. And we have to make best effort to develop our own and not to overdo it in order to work in a constantly changing environment and still make it perfect for space.
Wise words. Thank you, Ran. So we're approaching almost the end. It's the last questions for each panelist. So if you guys have, I'm talking about now the audience, if you have questions, start thinking about it and feel free to write it down on the Q&A chat so we can ask them later at the Q&A portions. We're gonna, in a few minutes, open it up. But before that, Lieutenant Y, recently at Starburst, we're supporting more and more international collaborations between government that creates innovation programs that are targeted towards AI, like we did for the NASA Entrepreneurs Challenge or the Allied Defense Accelerator, which is a grand coalitions of multiple armies together, the Brits and the Americans. And basically they're brought together to find the fund, and they fast track the best ideas from startup innovators around the world to the front line. So it's becoming clear that to the DoD organizations that there's a need to accelerate and scale commercial technology across the military to solve national security problem. And I know that you, because when we talked before, you mentioned that you recently participated in the XView Challenge, which was launched by the Defense Innovation Units, that focuses on applying innovative computer vision solutions to assess building damage that uses satellite imagery for natural disaster scenario or situation. So my questions are the following. One, what are some of the insights that you've learned from this challenge? And second, where do you see this type of collaborations heading, and what do you hope that this trend will eventually achieve in the future?
So I think in general, it's very productive for a team to approach some challenge in a subject which they don't know. We try to participate in as many challenges as possible in subjects unrelated to our work, just to become better at what we do. It's like Insta research. You don't have to work hard to gather data. You don't have to work hard to understand which is the best problem to approach using your data. You just have a problem, and you can become more professional and a better teammate by working together on the same problem. And it's very productive, and I recommend it for anyone who manages a team such as ours. I think it's extremely interesting that we can just outsource our problems to the citizens, because it's very productive for both sides. People can approach unknown problems and gain more experience, and we can have hundreds of dedicated professionals working on our problems for extremely cheap. So, and I think all sides benefit for that. Israel's Directorate of Defense Research and Development, MAFAT, also published their own challenges recently, the MAFAT Challenge. They published a radar challenge, which is very unknown, which is not it's not common outside of the army to work with radar, or professional settings to work with radar. So I think we'll just see more and more of that, because it's so convenient for everyone.
That makes sense. I like how you said outsourcing to citizen. I found it very poetic. Cool. So in addition to more and more collaborations, what we've seen are also defense organizations like DARPA, or the Army Artificial Intelligence Task Force, that is already experimenting some ways to improve autonomy in an unmanned vehicles, and they try to build the trust in that autonomy between the platforms, the operators, and the commanders that will deploy them. So Roy, the next question is for you. Besides building trust in AI, what do you think are some of the key challenges that we will face to develop a fully autonomous drone technology? Whatever level you said was before, above 5, I guess.
Sure. So when it comes to AI challenges and the autonomy challenges, I would divide it into two groups. One that deals with the drone mobility, and the other one that deals with the mission itself, or the inspection mission, autonomous mission. So let's start with mobility, and I'll try to be brief. When it comes to mobility, fully autonomous missions require full redundancy, and those autonomous AI technologies will need to completely imitate the pilot's ability to understand the ever-changing surroundings of the drone, of the aerial vehicle in real time. And they will need to do it with very limited resources up in the air. And so the main things that we're talking about in the area of autonomous vehicles, it's navigation and landing, detect and avoid against aerial vehicles, and obstacle avoidance close to the ground. And those autonomous drones will need to be able to deal with all those challenges simultaneously. And when we talk about limited resources, we're talking about limited communication, we're talking about GPS or compass that can fail, we are talking about limited flight time and limited computing power. So at the end, to enable all of that, you need very strong technologies that can use those limited resources in the air and still perform the mission. And we also, when we are talking about the scalable market, it's all about cost and weight, and everything has to be minimized with minimum cost. Sounds simple, no? And when it comes to the inspection mission, I think the key question is effectiveness of the mission. I'll give you examples. When you're using cameras in real-time missions, you have a clear trade-off between the ability to cover large areas and how to create, for example, common language between multiple drones. And when you get to the mission itself and you investigate a limited area, you need to collect a lot of pixels on a given target in order to fully understand what's going on in the scene. And all of that requires AI training. So the bottom line, because I don't want to take too much time, the bottom line is that it's a very complicated mission that one needs to break into small pieces, and each one of them needs, in the coming years, we need to make a significant advancement. The good news is that the market is heading there very fast.
It's good to know. Thank you, Roy. Renana, my last question is addressed to you. We want to basically understand what the VC ecosystem think, and I guess you're representing them tonight. So besides the booming aerospace industry, Israel also has a very strong AI ecosystem that attracts both investors and big corporations. And we've seen a lot of acquisition by industry giants lately that is mostly led by Google, Apple, Facebook, Amazon, and Intel. Just in the last month, Apple secretly acquired an Israeli startup called Camera AI, or Camerai, which is developing a camera technology. And a few months before that, Intel bought another Israeli startup called Habana, or Habana Labs, which develops chips for AI applications for $2 billion. Both of these acquisitions are dwarfed in comparison to the 15 billion acquisition of Mobileye by Intel, and most recently to the 6.9 billion acquisition of Mellanox by NVIDIA. So my question, Renana, is how do you see these AI Israeli tech mergers and acquisitions fit into the global aerospace and defense ecosystem? And is there any new Israeli unicorns on the horizons that you can share tips with us? And according to you, which countries are leading the race to AI? It's really 3 questions, I know.
It's 3 questions, so I got 3 minutes. I'll quickly answer the first one because I think we touched upon it quite a bit. AI today is everything. It crosses every vertical, and I think even in the examples that you gave an example for chips for accelerating AI. That's hardware and semiconductors. That's a huge market of its own. And then you gave an example of a software company and then of services. If I'd be able to name a unicorn, then I'd be in a great place. I don't know to point a specific one, but I do know that all of those fields, AI-specific solutions, AI services platforms, semiconductors for acceleration of AI, those are all areas that we're closely monitoring, and I'm sure they're going to boom. And so that's relating to interesting AI verticals. Now, you asked, and it was towards the end of your question, but I think it's a really interesting question. You've asked, who is leading the AI race? And that's still debatable, because when people hear about the race for AI dominance, then they often think that the main competition is between the US and China, right? Like everything else. And both of those do have most of the largest and most well-funded AI companies on the planet. The pace of funding, company growth, adoption, it won't be slowing down anytime soon. But if you look closely, then you'll see that there are a ton of other countries that also have a stake in the AI race. Okay, France and Israel and the UK and the United States, they're all equally strong when it comes to AI. And China, Canada, Germany, Japan, I think South Korea is the last one, are equally close in their AI strategic strength. AI startups are raising ridiculous amounts of money, many billions each year. And most of the funding is indeed concentrated in the US and Chinese companies, but the source of the funds is much more international. And I think that it's because what makes AI as a technology sector different from previous major trends of investment is that AI is seen as a strategic technology by many governments. And there are a ton of government initiatives surrounding AI. China, I think, was the first one in 2017 or 2018 to release a 3-step program that's outlining its goal to become a world leader in AI by 2030. That's the goal. China, other than the government, has, of course, many multi-billion-dollar tech giants like Alibaba and Baidu and Tencent and Huawei, who are each investing by their own heavily in AI. And the United States, around the same time, issued an executive order from the president naming AI the second highest R&D priority for the fiscal year of 2020. Now, in case you're wondering what's the first, it was the security of the American people. I mean, that's the priority. And South Korea government, the UK government, Japan, France, Germany, they all announced billions of dollars of government initiatives to support AI development. And of course, there's Israel, which is another power horse. There is a concentrated effort in Israel across academia and industry and government and society to further improve on what's already an advanced position globally. And much, of course, thanks to our ever-thriving startup scene. There are close to 1,000, I think, last time I checked, AI startups across various levels of maturity, which is, of course, attracting significant international attention. And I think that the question is, who rules? We rule.
I like it. It's a very politically correct answer as well. Basically, there's no winner. For now, the race is still undetermined. So we'll have to stay tuned and see who's going to win in the next 25 years, or whenever the singularity point is arriving. So I think that's all the time we have for questions. I want to thank again all my panelists for participating. Hernan Ashkenazi, Shmuel, Professor Ron Ginosar, and Lieutenant Y. I would like to opening up now to questions from the audience. I will give you some time to think about it and ask. We talked about a lot of things today, border surveillance and safety for autonomous flight, and swarm intelligence, and AI-powered chips. So I'm sure that the questions could go either way. Avital, do we have questions? Just give me signs when we do have questions. And while people are writing questions, I'm just going to go through the list of VIP that accompany us today. And more than 150 people registered for this panel. The panel will also be shared on our YouTube and on our social media pages. So for those of you who couldn't make it, you have a chance to watch it later. And we have someone from Dassault Aviations with us today in the AI world mapping departments, someone at the ImageSat International. Hi, Israel Lupa from ELTA. Good to see you. I know him very well. He's one of our corporate partner. And Ofer Lapid is here. He was in our previous panels before. Hey, Ofer. And we have people from Aerospace, Defense and Space, from Safran, from USSF, which is the US Space Force. I think that's my first one. Amazing. And Hyundai and Elbit and NASA. And then someone from the Tesla Foundation, the chairman and CEO. It's not the same as Tesla. I looked it up, you guys. It's different. And German Aerospace Industry Associations and HP Indigo and US government. So, and Korean Innovation Center all the way from Korea. That's amazing. Thank you, Jung Moon. I hope I said that correctly. Cool. Without further ado, we have first questions from Itai Rice. Hi, Itai. His question is as follows. Using AI in commercial aviations will most likely begin with cargo planes. Are you aware of any companies trying to develop AI for this aspect, or any research, or are there any research done in this field? So whomever in the panel wants to answer this one, it's a free for grab.
I actually met a company just recently that's not looking at aircraft cargo, but cargo at sea. And what they're doing is tracking cargo to understand basically what they're saying is that today you can only understand damage once the cargo is delivered, once the ship has docked. And then it's A, too late, and B, you don't know who's to blame, right? And so they're using sensors that are already installed on the cargo to identify what happened, when did it happen, and who's at fault. So it's not aerospace, but it is cargo. So if that answers the question, then they're called True North, and I think they have huge potential.
Okay, thanks. I think that answers it. Any more questions from the audience? So, unless I see more, I think that's all for now. We're also a bit behind schedule, so we're gonna have to cut that short. So I want to thank everybody for joining us for this virtual roundtable today and for sharing your insights about the future of aerospace and defense, which is also spotlighting through the lenses of artificial intelligence. I want to thank Avital Vilkin, who works with me in the Israeli office, and the amazing Starburst Global team for helping me put this together. I would like to show you guys the agenda, which should pop up on your screen so that you can see what we're working on next. While Avital can put it up. And then our goal always, just to remind you, is to bring insightful content around interesting innovation topics and to create successful win-win collaborations opportunities within the global A&D ecosystem. Starburst is in the planning stage for a joint initiative for space-focused accelerator in Israel, in cooperations with the government and corporate partners that will focus on leveraging Israel's strength and potential for growth in various fields, some of which we've spoken about it in this panel tonight, including downstream applications, sensors and data fusions, applied science and enabling technology. So whoever's listening, if you think that your organization would be interested in joining these initiatives, we would love to hear from you, and you can feel free to contact me. I would like to maybe finish with opening the panel for any closing remarks and give my panelists a chance to say the last words. And we're gonna do it by order. So whoever's first on my screen, Ran. Any last
short comment about Renana mentioned earlier the issue of privacy in response to your question, and also she mentioned a different answer about the how the Chinese elite is golfing. So we hear a counter argument about privacy that is related closely to facial recognition and other type of recognition, that we value privacy a lot, and the Chinese seem to not value it at all. And what they say that helped them contain movement of population in the recent months. And as a result, their per capita number of dead people out of COVID-19 is significantly lower than that in the United States, where privacy is relatively highly valued. However, the price you pay for it is in many more lives that are lost. It's interesting philosophical point of view or cultural.
For sharing that. And Roy, you're next. Any last closing remarks?
Yes, Ram actually mentioned that the COVID-19 and what we are actually learning from that, and in the past few months, we are seeing a higher demand, different type of applications around different needs that we see today in the market, following the different challenges of COVID-19. You see that in drone delivery, you see that in security and police missions and inspection missions. And as I think the technology will evolve and the understanding that the use of small autonomous drones and do that in a smart and safe way will really open up the sky for so many opportunities. And I think we are going to face a challenging but very exciting next 10 years and beyond in this market.
No doubt. And Renana, you have the last of the last words.
The last, because you can't see Lieutenant White. I actually wanted to close with some thoughts on new space, because for some reason we didn't talk about new space and space tech. And those are things that we're looking at quite heavily recently. You know, it seems that the monopoly of space that was held by national governments is over, and over the past decade, and probably in the last 4 years in particular, space has become more accessible, more private, more entrepreneurial than ever. And with private actors that are now playing an increasingly important role, bringing a new generation of innovative, affordable solutions through the entire launch vehicle payload and launch infrastructure system. And we see simplicity and reliability and sharply reduced costs, and Roy mentioned it earlier, becoming a new necessity. And it seems that the sky, in terms of potential disruption to this multi-billion-dollar space industry, is literally not the limit.
Thank you, Renana. Indeed, Lieutenant Y, sorry, I didn't mean to offend. Do you have any last words for closing remarks?
Yeah, I think in the last few months, we have all seen GPT-3, which is language model developed by OpenAI, where they didn't do anything except basically take technologies that existed for some years and just invest more into them. They trained the model on the entire internet using a budget of about $10 to $20 million. It's been assessed, and they got incredible results. So my point is, AI scales up extremely well, and I think we're going to see, even if the technology stopped right now, I think just by pouring more money into this area, I think we will see incredible stuff that we have yet to see.
Thank you. I'm, for one, very excited about what the future has in store for us. And that's a wrap. Thank you, everyone, for participating. See you next time.
Thank you.